The element that does not belong to the same period of the remaining elements of the modern periodic table, it is a question from either D and F block elements or from periodic classification of elements. If I am going to take palladium, so we know that nickel, palladium, platinum. Palladium belongs to the 4D series. 4D series is nothing but the fifth period. If I am going to take iridium, osmium, platinum, all these are 5D series elements which belongs to the sixth period of the periodic table. So which does not belong to the same period, palladium option 1 is the correct answer for the given question. The incorrect statement among the following is NH3 shows lower proton affinity than NH3. So the base which is said to be a strong, having high proton affinity, if the base is said to be a weak, which is having low proton affinity. So that means that they have the least tendency to accept the proton. pH3 is a weak base when compared to NH3. NH3 is relatively a strong base when compared to phosphine. So option 1 is correct only, but it is not an incorrect statement. PF3 exists, but NF5 does not exist due to the absence of empty d orbitals for the nitrogen. N cannot form the 5 bonds, so NF5 does not exist. It is also correct only. NO2 can dimerize easily when you are decreasing the temperature. NO2 molecules dimerize to form N2O4, which is also correct answer. SO2 can act as an oxidizing agent but not a reducing agent. So if I am going to take SO2, the sulfur oxidation state is +4, which is an intermediate oxidation state because the sulfur exhibits -2 oxidation state to +6 oxidation state. This is the maximum and this is minimum. Whenever any element shows the intermediate oxidation state, then that particular compound can both act as oxidizing agent as well as a reducing agent. So SO2 is acting as an oxidizing agent but also behaves as a reducing agent, but it is not a reducing agent is given, so it is wrong answer. We have to identify the incorrect option. Option 4 is the correct answer for the given question. And the next one, the D electronic configuration of an octahedral cobalt-3 complex having magnetic moment 3.95 bm is. If the magnetic moment is 3.95 bm, we know that the number of unpaired electrons are 3. So we have the formula for the magnetic moment is equal to square root of n into n plus 2 bm. 3.95 bm is the number of unpaired electrons are 3. So in which configuration cobalt 3 plus is having this particular 3 unpaired electrons means here already given cobalt 2 plus configuration 4s0 3d7 4s0 3d7 and that should have 3 unpaired electrons and it is an octahedral complex. So according to crystal field splitting energy, T2z orbitals are present at the bottom and EZ orbitals are present at the upside. If it is a weak field ligand, first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron, 3 unpaired electrons are there. So which is having the configuration T2Z5 and EZ2 configuration. T2Z5 and EZ2 configuration is there on option 3, which is the correct answer for the given question. So here it is the question from coordination compounds, the complex that shows spatial and meridional isomerism. So the complexes which are of the type Na3B3 can exhibit facial and meridional isomerism, fake and mer isomerism. Ma3B3. So the first one, it is in the form of Ma3B3 C1H3Cl3, which can show facial and meridional isomerism. It is of the type Ma4B2 that cannot exhibit. It is Ma thrice 3 plus because in the form of ethylene diamine, it is a bidentate ligand, and that can exhibit optical isomerism, not geometrical isomerism. COEN twice Cl2 plus can exhibit both geometrical and optical isomerism. So option 1 is the correct answer for the given question. So the question from the D and F block elements. Here the question is the correct set of aqueous solutions with the same color from the following is. So we have to identify the ions with the same color. So we know that V2 plus having unpaired electrons, which is having violet color, and Cr3 plus is also having violet color. Mn3 plus is also having violet color. Zinc 2 plus having no unpaired electrons, no color. Scandium 3 plus having no unpaired electrons, no color. Titanium 4 plus having no unpaired electrons, no color. So option 1 is the correct answer for this given question. So molecules obeying octet rule. This is a question from chemical bonding. Molecules obeying octet rule, if you are seeing this particular one, if I am going to take CCl4 and CO2. CCl4, the central atom carbon having 4 bond pairs and 0 lone pairs. The C is also having 4 bond pairs and 0 lone pairs. 4 2s are 8, it is having octet. So the correct option for the A is 4. Molecules with incomplete octet. Incomplete octet means the central atom utilizing its all valence electrons, but the octet, it is not available for the central atom. Even if it is utilizing all the valence electrons, it did not get the octet. For example, if I am going to take BCl3 or AlCl3, the central atoms are boron and aluminium. Each one is having 3 valence electrons. 3 are involved in bonding. So that's what is having 3 bond pairs and 0 lone pairs. So 3 plus 0, 3 sp2 hybridization. Only 6 valence electrons are present, incomplete octet. Such molecules are called as electron deficient molecules. So the correct match for the B is 2. Molecules with the incomplete octet and odd electrons. If I am going to take NO, nitric oxide, NO2, nitrogen dioxide, both are having odd electrons and also having incomplete octet. So the correct option for the C is 1. Molecules with expanded octet, sometimes it is also called a superoctet. So if I am going to take H2SO4 and PCl5, phosphorus is having 5 bond pairs. 5 2s are 10 electrons here. H2SO4 also, if I am going to take S double bond O, single bond OH, single bond OH. 1, 2, 3, 4, 5, 6, 12 electrons are there around the sulfur, which is also having expanded octet. So the D is matched with 3 here. So A4, B2, C1, D3. Option 1 is the correct answer for the given question.